Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Wenelect, and today we're going to be looking at ETL processes, specifically around the transformations that you can do with ETL in that context and how you can do that with Data Factory. Hi guys, today we're going to be taking a look at another video on Azure Data Factory. And in this video, we're going to be looking at how to do some basic transforms. Now, I'm not going to get into the details of every possible transform in Data Factory, but I want to walk through the process of ETL, and that is the extract, transform, and load, and then show you how that fits into the context of a Data Factory pipeline, as well as building out a data flow in Data Factory as well. So this video is going to cover a couple of different topics, but I'm going to start by looking at what we looked at last week, and that is actually building out a pipeline and what that looks like ultimately, and then we're going to kind of zoom in on part of that pipeline and look at transforms. So last week we looked at how to do data movement with Data Factory. We were basically just moving data around. We looked at how we could have a device that generates messages. In our case, I have a firewall that I'm using to generate messages and events from that firewall. And then there's something that collects that data and collates that data into some form. And then that process, that agent, moves that up into some kind of landing zone in the cloud. And this is a upstream process from what we've been looking at with Data Factory, but it's an important part of it. Now, there's a lot of things that we could talk about in that pipeline alone, and that's typically done by IoT or just some kind of API or some kind of data push from some other data system that's picked up. Regardless of where that data comes from, it ends up in some kind of landing zone in the cloud, typically Azure Blob Storage on Azure or something like that. And this is where the ETL process usually begins, is with that data store, whatever it might be. In that case, what we typically have is a data lake, and we do an extract from the landing zone into the data lake. And that's the E in ETL. So the extraction of that data usually involves some data validation or something like that, usually pretty lightweight. There's no massaging of that data, no transformations or anything like that. It's basically just moving it as is from one data system to the other and just making sure that the data itself is good data before we do any kind of processing of that data. And when we take that data out of its landing zone or wherever it comes from into the data lake, that part is called moving it into what we might call a bronze tier for our data. And the bronze tier is the first of three tiers of golds, and silver being the other two, which are kind of downstream of what we're going to be talking about. So we do an extraction and we land it into the data lake and call it bronze data or bronze tier. And that tier is basically just the raw data as it existed in that landing zone. So from here, we can then do transforms. Now, the transform is where we take that raw data, and that raw data can come from a number of different data sources. So don't think of this pipeline right here as being a single source of data. Think of this as being multiple sources. It could be an API, it could be devices, it could be external data pushes. It's a lot of different things that are all ending up putting the data in the cloud. And then this extraction process kind of takes all of that data, regardless of where it comes from, and then pushes it into this bronze tier. So it's basically responsible for grabbing the data from all the data sources and then landing it in the data lake in its raw form without transforming it or anything like that. The transformation process starts taking all of that data that you're getting from all these different sources and doing some transformation, some aggregation, some join, some filters, all of that kind of stuff on it. And that's the T and ETL. So this was the E right here. The T is going to do that, all that joining and aggregation and all of that kind of work on the data. And then once it's done, it's going to land it in the data lake again, but it's going to be what we call silver data or silver tiered data. And the silver tier is data that is better and more collated and more enriched than what you might have it in its raw form. And this is the data that you can actually use for querying. And this data is typically represented in a schema that we call a star schema, which we're not going to get into today. We're going to cover that in a future video. But the data that ends up in this particular silver tier is data that we're actually going to be working with so that we can actually produce something that is downstream of this, which is done by the next step, which is the load. So we take it out of that data lake in that silver tier, which is typically represented in the star schema. It's more general. And we take that data and transform it, maybe do some massaging on it, and ultimately make it very specific to whatever application that's going to be consuming it. And that's what we call a gold tier. So that golden tier is data that is ready for loading into an external data system. And that external data system could be something outside of the data lake. It's typically like a database or some kind of data warehouse or something like that, that then can be used for reporting or APIs or whatever the downstream use of that data might be. And this process of loading is very specific to the application that is intended for the data. While this data in the silver tier is not that specific application, it's more general in its use case as in that presentation. So this right here is what we might call an ETL process. And so last week we basically looked at the extraction of data, and today we're going to look at kind of the transform of the data. And next week we'll look at doing more of this load and also look at star schemas. But the idea of doing data transforms in data lake is basically going to be taking data out of a data lake in one part of the data lake and shifting it to another part of the data lake. But the data format and a lot of the data massaging and the data joining and the data aggregation is going to be done in this transform step right here to get it prepared for the ability to query it, to use it, to make some kind of sense out of that data so that we can then turn that into something that can be consumed for reporting or APIs or whatever the external data source might be. I'm here in the resource group where I've been working with my data, and the storage account that I'm writing my data to now is this one right here. And this particular storage account is the one that I am basically taking the data off of the device and dumping it to in the cloud. And I've broken this up a little bit more intelligently than I did before. Last week when I looked at this, I just basically had the raw logs in here. And that is fine for data movements and that kind of thing, if that's all you're concerned about. But if I'm going to be doing some kind of data transforms, I want to get my data in a form that's going to be much more simpler to work with. Now, what Data Factory does well is it's good at taking data and working with the data as a set. So what I want to be doing in Data Factory is doing data transforms. What I don't want to be doing in Data Factory is trying to take a big bucket of unorganized data and trying to sort that data out based on a property on each one of those particular messages. Now you can do that in Data Factory, but it's just not a real good, efficient use of what Data Factory is designed for. So rather than let Data Factory handle that, I made my agent a little bit more intelligent. It basically looks at each message and then it puts each message into an appropriate presentation like this. So this is broken down by the message type that's coming out of my firewall. And this is the class that it gets written into one of these various folders. But underneath this, the structure is basically, the year, month, day, hour, minute scheme that we saw earlier. And so it's just adding a little bit more taxonomy to that based on a message type. Now, because that's done at the message level and I'm able to sort it out at the message level, that's something I can put on the agent. Or if I wanted to do it completely cloud side, I would probably run each of these messages through something like a function app or something like that to give me the same result, where I'm going to be presenting the data in something that's a little bit more structured than just raw data. You can do that, like I said, in Data Factory. It's just not very efficient way to handle that, while you can do this in something like a function app really well. Function apps are terrible for aggregating data or to summarize data. That's what Data Factory does well. So use Data Factory for that purpose. So let's take a look at what's downstream of this now. So here is my Data Factory IDE or my studio. And basically what I have going on here is a couple of pipelines. And what I've got going on right here is this pipeline right here that's still moving the data. Nothing's changed about this. The only difference between this and what we saw last week is on this storage account on the destination, as I'm putting this into a folder called FW logs. Inside of that, I'm putting it into a folder called new, and we'll look at why I did that in a minute. but it's basically taking it out of that particular storage account and then copying it into this folder right here. And then I am going to be using this as the source for my pipelines. So once I have that, I have now moved my data into my storage account, out of my storage account into my data lake, and now I can work with it using my transformations. And that's where things get a little bit more interesting. So inside of Data Factory, I was working with this, I'm going to delete this. And when I was working with Data Factory, there's a lot of things that we can look at. Last week, we just looked at pipelines for moving data around, which is a use case for just straight up pipelines, just moving data from one place to another. Now, another thing that you can do with pipelines is orchestration. And orchestration is basically invoking things like what we have down here in a data flow. Now, I was working with this just as a second ago. I'm going to delete that. I don't need it. And a data flow is the part of Data Factory that does transformations. So this is all about moving data around and orchestrating data flows. So there is a little bit of logic that you can put into these pipelines for the purposes of actually orchestration of data, but it doesn't actually work with the data itself. That's what data flows are for. And data flows are where you're going to do things like joins and filters and aggregations and all of those kinds of data specific things that work with the data as a set. And this is going to be orchestrating. You notice that I have a pipeline right here. Well, that pipeline is designed for orchestrating and running this particular data flow down here. So I still need to have a pipeline to invoke the data flow. So I'm going to be primarily looking at this data flow right here because this pipeline doesn't really do anything. It just calls the data flow. But I need to have that present to orchestrate the invocation of a given data flow. So this is my pipeline down here. So my data flow right here, and we're going to get into this in just a second, what that's going to look like. But what I do have as a part of this is data sets or sources, and that's what's defined right here. So kind of the elements of Data Factory are pipelines, data flows, and data sets. And we saw a data set last week when we looked at this pipeline here, but I'm mostly going to be interested in the data sets that this is going to be working with, which I have defined right here and right here. So if I was going to create a new one of these, I could come down here and create a new pipeline. It's pretty straightforward to do. I'm just going to create a new data flow. And then I'm going to add a source to this. Now, for my sources, I'm working with Data Lake. So Data Lake is basically going to allow me to set this up. I'm going to create a new one right here. And then notice I have a lot of different kinds of sources I can choose from. And I'm going to choose Data Lake Gen 2. And I'm going to continue and choose JSON data. And JSON data is going to tell me what my link service is, and that's my Data Lake 2. In this one, I'm going to work with that new folder. So I'm going to drill down into this particular folder right here, go to new, and then I'm going to choose the class of object that I'm going to be working with for this one. And this one, I'm at Firewall Events. And then click OK. Now, what this is going to do is infer from the data that's in this particular folder. It's going to infer what the schema is for it. And if I go over here to projections, we can see a sampling of that. We can see the fields that's going to be represented here. And this is why you probably want to be able to get your data into the most defined form that you can before you actually start working with the data transforms, rather than just fork loading everything into a data source. Because if you do that, it's going to infer a lot of data here, and it's going to have a lot of columns that may or may not apply. And that's one way to handle it. It just makes handling and wrangling the data a little bit harder to do. So if you can do that prior to using it in the transforms, that's probably a better practice. However, that doesn't mean you can't work with it in this kind of context. In any case, these are the fields that are on this particular data source right here. And that's the one I've had defined. So I'm gonna go ahead and delete this right here since I really don't need it. I can look at this right here and see that those are the same 7 fields. And this is just data from a firewall event coming off of my firewall. And a firewall event is just where something crossed the firewall and it invoked an event, and it tells me which rule invoked that event. Now it either allows it or blocks it, either flags it or doesn't. It gives that timestamp and it tells me what rule it did. Now, in a future video, we're going to look at correlations and building what we call a star schema based on some of this data right here. But for today, we're just looking at transforms. So let's take a look at the other one that I'm going to be working with, which is the session event right here. Now, this right here is a session ID, which is the event that this is associated with, which is a session event. Now, session events apply to everything on the firewall and the appliance. Really, it's something that's going on the appliance. It doesn't mean that it crosses the firewall. If it crosses the firewall, then a firewall event gets triggered. And this tells me everything about the event that I probably want to know about beyond the rules and things that are part of this particular object up here. And this is going to have the correlation between the session ID, and then this is going to tell me stuff about the protocol and so on. It's going to tell me, the protocol, the IP addresses, the ports, the timestamp, and a lot of things related to information about that particular TCP or UDP session that was being handled by the firewall. And then what my data flow then does is it works with those two data sources, and it does a simple join on it. So if I come over here to my join, you can see I'm doing an inner join. You can do full outer joins if you want. That's where everything in both table gets represented. You can do a left outer join, which is basically everything in this table gets represented. If there's correlation, it'll represent that data right. So everything in this source too. And then cross custom is what you can work with there. Inner is what I'm interested in because not every session has a firewall event associated with it, because there's things that my appliance handles that don't cross the firewall. So that's a particular distinction that my firewall appliance really does. So I'm basically just looking for the intersection of these two, which is then going to join those two together. And then what I'm going to do is join them on the session ID. And if I look at the data output from this, is basically going to give me a list of columns that I'm going to be writing out to. Now, since I don't have data preview turned on, it's not going to give me a sample there, but I can look at an output from this in just a moment. Now, this is what it's going to output in terms of columns. It's basically the intersection of those two. So it's going to have the columns from both of my data sets in this particular presentation. And so that's what the join does. Now, if I wanted to do other data filters on this, I could actually filter on this. So just to show you what that might look like, if I wanted to look at some of these other kinds of things I can do with transformations, is I can do logic branches. So if I wanted to do like sorting, like I was mentioning in a data transform, I can do that with a data flow. I could say, I dump all my data into a bucket and then sort it based on the class. I'm not going to do that. It's just not efficient. Exists is where you can look for, does it exist or doesn't exist. You can union data. That's just joining two like data sets together into a larger superset. You can do derived columns, basically calculated columns, aggregates. That's where you do summaries, averages, sums, those kinds of things. Pivot, that's where your rows become columns and your columns become rows. And unpivot, kind of the same thing. You can go the other way. Windows are basically a slice of the data, be time slice. Ranks is going to organize things. Other things you can do with it: flatten can do flatten hierarchies. Parse can read JSON or XML into if you have data that's coming in as just raw JSON data, you can parse it, and rather than use the data sources, if there was something about that, and you could use parse or flatten for those. And then this is where you can filter, alter row, filter data. And then finally you have the sync. So the sync right here is the output from a data flow. Now you generally do want to sync your data. Otherwise, why are you doing a transform? And this is why we do a data lake to data lake sync. Now, when I look at a data sync, and this is important to think about here, we don't want to use we don't have to use JSON data here. In fact, that would kind of be an anti-pattern, because there are more optimized formats that you can use with data syncing that are going to be more conducive for outputs. And the one that is preferable on something like a data lake working with the data factory is Parquet tables. So if I come over here and I look at my data set here, and let's open this guy up, I can see that I have the place that it's going to write to. It's going to tell me this is writing to a folder called FW data, and it's going to have my events as an output folder that's got the two mashed up. But it's using a Parquet table, and this is defined by this data set right here. Now, Parquet is a data format that allows me to do some queries on. It's not a database, but it does give me a columnized or columnar presentation of the data, a table that does support schemas and that kind of thing. And it is queryable and it is indexable and that kind of thing. And it will partition the data. And so this is a little bit more intelligent for working with data in something like a data lake or something like that, rather than writing it to CSVs or back to JSON data, because this is going to be much better performant, have much better performance than something like just using raw files like CSVs or JSON files. There's a lot less parsing that's got to be done when you're working with Parquet tables. So if you're gonna be using this data in another data flow, it's probably best to write it to a Parquet table and then use the pick of those Parquet tables up, and which we'll be doing when we look at our loads. When we actually do some more data transforms on this, and we'll look at our loads, we're going to read some Parquet tables and maybe write it back to other Parquet tables that we can use for presenting this data, and so on. So all in all, this is the output from the transform. Now, going back to what we talked about earlier with ETL, transforms are where we're moving it into that silver tier. So that's why I have this put out into another container inside the data lake. So it's basically writing it to another container there. So it's segmented away from it. And so I'd probably do something similar to my gold data, is write it to another container, another folder, depending on what your context is. Basically, it's just another storage container for that data. And now what I am doing with this data, and getting back to that new and archive folder that I have, is down here in my data flow. If I look back here at my sources, once I read this, if I look at my source options right here, and I say no action right here, that's because I was working with it. If I wanted to more intelligently work with this, what I would do is I would want to move the data once it's been processed. I would want to move it from one folder to another. And the reason why is so that the next time this runs, it doesn't pick up all that new and old data to rerun it. So it basically allows me to basically move it from one folder to another and just keep rolling forward on new data only, rather than trying to filter out old data every time that I try to work with this, because that can get really taxing as your data set grows. So you want to be able to specify only work with a subset of your data. And there's a lot of different ways to do that inside of Data Factory. This is just one that's pretty straightforward. It doesn't cost anything to move it because it's not actually doing a copy, it's just doing a data move. And so if I go like this, from new, and I put this into an archive right here, all of my new data is going to end up inside of my new folder, and then it's going to be moved over into my archive folder. And then that way I'm not deleting the data, I'm just moving it from one source to the next. And that way I am able to pick up the new data only the next time this runs, and then run the aggregations or the joins, whatever I'm doing, and then sync that data. So I'm only going to be getting new data into my data sync rather than trying to reprocess everything every time. And that will help keep your cost down as well. So some options for that right there. And you could do that on both your data sources. I think I have it turned off on this one too. I do. And so I could do the same kind of scheme here. So something to think about. So once that runs, you end up with Parquet tables. So let's go look at the output from this, which is going to be back in our data lake. And I'm going to put in this FW data. And this is the Parquet table right here. And it's basically partitioning the data into using some what they call snappy compression. It's just a compression algorithm, and it's using the Parquet format. And this is a format that I can then use for working with transforms in the future. And it's, again, you're going to have much better performance than just reading raw JSON files. So that's all I have for today. In our next video, we're going to look at how to build a star schema. And the star schema is an interesting concept because it's a way of presenting data in a data lake that is optimized for fast queries. And so it's very optimal for working with large data sets. And we'll look at how to build a star schema in our next video. And then we'll do some queries to work on data transforms and loads out of that into form that we can then use for our final transition into that gold state. Running a data flow is pretty straightforward. We just need to create a pipeline for that. So I'm going to go over here and just show you that it's pretty straightforward. Create a pipeline. You can name it whatever you want to. And then you go over here to move and transforms and you drag data flow onto the canvas. And this is where you set the properties for the data flow to run in what we might call the production environment, if you will, where you can set, the core count for your particular cluster. You can go up to 256 cores for large data sets. 4 is going to be fine for most of my stuff for demonstration, and even for some even larger data flows if they're not real data heavy. 4 is usually a pretty decent cluster for doing a lot of that kind of stuff. So that's what I need for this particular data flow to run. And I can just use this to invoke it. Now, if I wanted to debug it, I would need to turn on the debug cluster right here. And then I can click on debug right here. And then that will invoke the job and then I can view the output while it's running inside of Data Factory. So I've already run this. And so I'm going to show you the output, which we've actually already seen, which is these parquet tables right here. So if I look at the parquet table and download one, I can download one of these. It's pretty straightforward. If I wanted to view these more so than what I could get inside of Data Factory, because Data Factory's view is only basically the data preview, I can use this Parquet Viewer exe right here. This is a GitHub project. Just Google Parquet Viewer and you can get a link to this, and then you can download it to your local box. And this is the UI for it. You file open Parquet file right here, and then it'll display the table for you, and you can query the data and do other things like that. But this particular one is just showing me the data that I did in my join. So it's giving me a little bit more of a detailed view of what that was expressing. And this is just showing me the join. It's got all the columns that I had in my data sync. It's even got the file name column for the actual source of where it read the data from, the raw JSON file. So this is just showing you the output from that. So the actual running of a particular data flow is going to generate these, and this is what I'm going to be working with when I actually do some more work with future transforms that we're going to talk about next time when we start to build out some of those more sophisticated star schemas and actually doing some data loads into some external data systems.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.